Hello viewers, this is the second video on converting whole circle bearing into reduced bearing. In the first video I told you about the meaning of the whole circle and the reduced bearings, and now I'm going to tell you how to convert the whole circle bearings into reduced bearings. So let us take few examples. For example, we have let's take 4 degrees whole circle bearings like 40 degree, then we have 120 degree, then 200 degrees and 310. Why I have taken these values? Because I want the values to lie in the 4 quadrants so that I can show you how to convert the whole circle bearing into reduced bearing in all the 4 quadrants. So if we are going to solve the first one, it is 40 degree. So now this cross basically represents the directions. Now this 40 degree means that 40 degree angle is made by a line with the knot. That's why again you have to see the 40 degree. That's 40 degree is more than 0 and less than 90. That means it is coming in first quadrant, and the angle that the line makes with the knot is 40 degree. Okay, so in the first quadrant, this is first, second, third, fourth. In the first quadrant, the conversion is very simple. You just have to mention the quadrant in which it lies, that is north and east, and in between you have to write the value of the angle that the line makes with the knot. Okay, so since it is already given 40 degrees, so you just have to plot it here. So if this is the whole circle bearing 40 degrees, then the reduced bearing is RB is equals to not 40 degree east. Coming to another example where the angle lies in the second quadrant. For example, the WCB is 120, okay. Now since 120 is more than 90 and less than 180, so it will come in the second quadrant, and this WBC to 120 degree means that this angle is 120 degree. And what you need, for converting this bearing to reduce bearing, you should know in which quadrant it lies. You already know that it is lying in the second quadrant, and also the angle that it makes with the meridian. So here, this angle you want. Since we know that this line represents an angle of 180 degree, so for converting we have to write, since we know that the line is lying in the second quadrant, we will write south and east, and in the center we will write 180 degree less 120 degree, isn't it? Because this whole is 180 and we know that this is 120. To know this, we have to subtract 120 from 180. So the angle here is 60 degree east. So when you have to convert the whole circle bearing of 120 degree that is coming in the second quadrant, you have to subtract the value from 180 degrees and get the result of the reduced bearing. This one is the RB. Coming to the third example, that is we have WCB as 200 degrees. Again you have to mark all the directions. 200 is more than 180 and less than 270, so it will come in the third quadrant. And what WBC 200 means, WCB is, this angle is 200 degrees. So what do we want? We want to convert this whole circle bearing into reduced bearing. So RB is equals to, what do we want to know? We want to know which quadrant it lies. It is, from here we can see that is lying in the third quadrant, means S and W. Then how to find this angle, isn't it? You have to find out the angle that this line makes with the north-south line. Okay, so we already know this angle and we know that this line represents 180 degree. So we can subtract 180 degrees from the whole circle bearing, and here we will get as 20 degrees west. So this is the reduced bearing for the whole circle bearing 200. Next, let's take another example where the line is lying in the fourth quadrant, that is when whole circle bearing is 310. 310 is more than 270 and less than 360. So it is coming in the third quadrant. Now since it is coming in the third quadrant, we will simply write that reduced bearing is equals to north and west. It is in the third quadrant, so northwest we have to write, and in between we will write, what do we need? We need this angle, isn't it? And we already know that this angle is 310. So we know that this complete circle is 360 degree. So what we have to do, we will subtract 310 from 360 degrees and we will get this angle. 360 minus 310. So from here we get north 50 degree west. So when we have to convert the WCB of 310 degrees, we get the answer of reduced bearing as north 50 degree west. Let's see some other examples. Of converting reduced bearing into whole circle bearing. So here we will see how we can convert the reduced bearing into whole circle bearings. So here are some examples. In these examples I have given consideration that all the four values come in four different quadrants. So let's take this example. Here it is written that north, the reduced bearing is north 20 degree east. Okay, so north 20 degree east, reduced bearing is north 20 degree east. That means what? That means that the line is lying in the first quadrant and there is a 20 degree deviation of line from the meridian which we are considering. That means this. So now since it is again in the first quadrant, it is comparatively easier. You don't have to do much work. So you can write WCB is equals to, since it is already saying the angle that it is making with the north, so you can simply write 20 degree is the whole circle bearing. Coming to the example second. Okay. North, east, south and west. Again, see the example. It is north 30 degree west. So this is lying in the northwest. That means here in the fourth quadrant. It is lying in the fourth quadrant, and the angle of departure from the meridian is 30 degrees. So we want to convert this into whole circle bearing. So what do we need? We want to know this angle. Since we know that the whole circle is 360 degree, so to convert into WCB, what we have to do is we have to subtract 30 from 360 degrees. Since we know this one is 360 degree, this is the whole circle bearing, and this is 30 degree, so we are subtracting 30 from the whole 360 degrees. Okay, so here it is like this, and the answer is 330 degrees. So for 330 not 30 degree west, we get the whole circle bearing as 330 degrees. Coming to the third example, it is written south 60 degree east. Again, we have to mark all the directions. It is saying south and east, so it is coming in the second quadrant. Fourth, it is coming in the second quadrant, so here it is. Then what is it saying? There is a departure of 60 degrees. This one is 60 degree. What do we want to know? We want to know the whole circle bearing, that means this angle. We want to know this angle. How do we know? Now whole circle bearing is equals to 180 degree. Since we know that this line represents 180 degree, 180 degree less 60 degrees. The answer is okay. This 120 degree. Okay. So for the reduced bearing value south 60 degrees east, southeast, we will get the whole circle bearing. For getting whole circle bearing, we have to subtract 60 from 180 degree. Why? Because we want this angle, and we know that this angle is 60 degree. Okay. Coming to the last example. Here, if the problem is south 40 degree west, so you again have to mark all the directions and find out south and west. So south and west, so it is lying in the third quadrant. Okay, now and the angle of departure is 40 degrees. So what do we want? We want to know the whole circle bearing, that is the angle that this line make with the north. That means this much. What do we have to do? We know that this one is 180 degree and we should add this 40. So the whole circle bearing is equals to 180 degree plus 40 degrees. So it is So it is 220 degrees. Likewise, we can convert the whole circle bearings into reduced bearing and reduced bearings into whole circle bearings. Thank you.